let's go ahead and start. Just the basics of robotics. A quick definition for robotics. It's an interdisciplinary branch of computer science and engineering. And robots can also have a bunch of different functions, and we use them in our everyday lives. So, you guys have all probably used a robot today, and we'll go more into that later. But certain robots require user input, while other robots can function autonomously, meaning they can function without any human input, or they can just function as if they have a mind of their own. And yeah, you can also see them in a bunch of different movies, like Wall-E is a robot, and BB-8 from Star Wars. All are examples of robots. So the origins of robot and robotics, R2-D2 and C3PO from Star Wars, and all these human-like machines. Those are kind of what we think of whenever we hear the word robot or robotics. And just some history. So the author, Isaac Asimov, I'm not sure if I pronounced that right, but he first used the word robotics in his short story in 1942. And in that, he came up with these 3 laws of robotics that his robots followed, and some other sci-fi authors also followed these laws. So the first law is that a robot cannot injure a human being or allow a human being to come to harm. And the second law, a robot must obey the orders given it by human beings, except if it would conflict with the first law. And then the third law is a robot must protect its own existence as long as its protection does not conflict with the other 2 laws. So hopefully that wasn't too wordy, but that's the general essence of the origins of the word robot and robotics. So here are the link in case anyone needs it. And as always, if you have questions or anything, definitely don't be afraid to ask or just type into chat. So just some more history. And I know there's just like a lot of history here in these slides, but it is important to understand like how did we even come up with robots, or those huge advanced robots we see today. Like how did we start off, and like how did we get to that point, which is an important thing to think about. So what are some of the first robots ever invented that look like, what did they look like? And maybe you have some ideas in your head, but honestly, they're pretty cool. So one of the first mechanical devices that was built to carry out a physical task, that occurred in 3000 BC, so that's just like really, really long ago. And it was the Egyptian water clock that used figurines to strike the hour bells. So if you see this image here on the right side, that's an example of an Egyptian water clock. And on top is not a human, it's like a dog-headed human figure that's sitting on top. And basically, they used, engineering and mechanics to have it strike the hour bell. And yeah, that was one of the first ever mechanical devices. Not sure if it fully counts as a robot, but it's one of the most early conceptions of a robot. And if you see on that bottom image there on the right side, that is a wooden pigeon. So in 400 BC, Archytas of Tarentum, might have pronounced that wrong again, but he was the inventor of the pulley and the screw. And he invented that wooden pigeon that could fly, and that image here is on the bottom left. So basically, these are just some pretty neat mechanical devices that have really unique designs and can perform the specific physical function, whether it be flying or striking the bell. And a little bit more. Hopefully, this isn't too wordy, but just to kind of sum up, in the 1700s, more and more robotic inventions were being made, and in the 19th century, there were also many more robotic creations, such as the steam powered robot, which you can see on the right side. That's kind of like a cartoon of, kind of like an exaggeration of the steam powered robot, but in essence, just a lot more robotic inventions being made. And especially in the 20th century, that's when robotics just really became extremely advanced. And I'm not sure if you guys have learned about the like industrial revolution yet, but that's when robots were used for basically everything and making all the products that you have in your home today. So yeah, robots just really are everywhere, even if you may not think so. Maybe like the bed frame you're on, or the table you're using, the nails in it were probably all created with robot machines. So now we're going closer just to like today's era or today's time. Now that we know how robots kind of first started or how they originated, as you saw before, the first robots were really simple. They were really kind of limited in their movement, and yeah, they just did really simple things. But in the 1950s, this guy, George C. Devil, he invented this manipulator called the Unimit, and that's kind of derived from the two words universal automation. And the Unimit is that top right image you see there. It's a little bit blurry, but it's really similar to the industrial robots used in factories and production, which is pretty cool. And in 1958, at the Stanford Research Institute, Charles Rosen led a research team in developing a robot called Shaky. And Shaky was a lot more advanced than Unimit. And Shaky is the robot here in the top, I mean, not top, but the bottom left. That guy standing next to it and almost as tall as the robot. So, this Shaky robot, as it was named, it could be used for really specialized and industrial applications. And Shaky could wheel around the room and observe the scene with his television eyes, and it was able to move across surroundings that it wasn't familiar with, and could also respond to his environment. And this was like probably one of the most advanced robots at this time, but it still obviously isn't as advanced as all the really cool robots today, because Shaky was pretty wobbly and had clattering movements, hence the name Shaky. So, still more improvements that could be made, but really cool at the time. And these are just one of the most well known, one of like the first modern robots. And yeah, so now we're practically done with the history. So we saw kind of what were the first robots like, and how did they develop, and how more advanced did they become? So we know that they started just really simple functions to just a lot more parts, just a lot more complicated mechanics, and a lot more functions. And today, robots are becoming just more and more advanced. So now we're going to just talk about some technical aspects of robotics, and that just includes what makes up a robot. And in this case, I'm more specifically talking about competition robots. So if you guys know of or have visited CCA, you may know of the robotics team Aluminum Narwhals. And there are some other robotics teams like that are FTC, meaning they're in kind of like the smaller league, but still make these really neat robots. So yeah, this technical part is more centered around those types of competition robots rather than factory robots or sci-fi fiction ones. And yeah, so here, when we have robotics for the first robotics, we have several main parts. So that's the mechanics, the controls, and software. So just in a really general sense, those are the three main parts. And here we have these images that we'll go more into later, but going on. So mechanics. Mech is responsible for designing and building the robot. And that seems really general, but for example, if you want to create a robot that can throw basketballs, the mechanical team, they can basically develop the appearance of the robot and also the structure. So that means, oh, where should we place this metal rod or this wood plank? And yeah, mechanics, that goes just for like the backbone and just overall structure of the robot. And typically, obviously, there's not like super set rules of like what they can and can't do, but mechanicals doesn't really include the wiring of the robot, as that's usually reserved for controls. But more on mechanics, they use computer aided design, which is also called CAD. So that's basically like this computer program where you can use 3D modeling and create different like shapes or create certain parts that you want to add to your robot. And that way you can fit them together and plan out how each mechanism will look. So you see here this GIF of this little robot kind of just zooming across the floor. We see those metal, it's kind of like in the shape of almost a like octagon or like a horseshoe. And a mechanics team, they would kind of put together those metal bars, and yeah, they are responsible for that general structure. And moving on. So another important part of mechanics in robotics is prototyping. So does anyone know what prototyping is? Well, it does say here on the slide already, but essentially prototyping lets you figure out problems in designs without costing time and money. So let's say you want to create a robot that can just, let's say maybe take the maybe separate tomatoes from strawberries. And that seems like maybe a crazy idea. And, you know, you don't want to spend your best materials, you don't want to spend a bunch of money by creating this robot that can separate your tomatoes and strawberries on your first try, because if you spend all that time and energy and money using all your highest quality materials and it fails, then all of that money and time would go to waste. So basically, prototyping is where you use really cheap materials and kind of like more of a loose design. So you can test things out, you can see what works and what doesn't. And yeah, summing up, it's using just much more cheap materials like wood or styrofoam. And it's important to spend a lot of time testing prototypes, which can also be really fun. But prototyping is really important, so that way you're not wasting time and money on you trying to make like the real actual robot without ever, testing things out and trial and error and seeing what fails and whatever. And yeah, so remember, prototyping always important if you ever get into robotics. So we'll move on. Alrighty, so FTC robot drivetrain. And not sure if you guys know what FTC is. Some of you may know, but FTC is the first technology challenge. And that's like this robotics league that's not the same as Aluminum Narwhals, which is the Canyon Crest Academy robotics team. It's like FTC is a smaller league which uses smaller robots, like the one you see here in the GIF. So a drivetrain, you may or may not have heard of this word before, but it's basically like what the word says. Basically, you want to drive. And a drivetrain is what moves the robot around the field. And the drivetrain is kind of like a mechanism. You want to be able to move around the ground obstacles, you want to reach objectives, push game pieces, carry game pieces. And yeah, also if you did join the meet a little bit later, if you're kind of confused about what obstacles or pieces are, this is just talking about the first robotics competition, which you probably heard about in high school or middle school. And if you don't know what it is, you guys should definitely look into it, or you can definitely ask me about it. And yeah, first robotics is just a really cool thing for students to be involved in if you want to get more into robotics. And yeah, here, this like technical part is centered around that robotics competition. That's really widespread, like almost in every high school, I think. So yeah, going back on track, you see in that GIF, there are these kind of little orange obstacles on that floor, and you can see the robot is kind of zigzagging across it. So that could either be like automated or a human is controlling it, but basically the drivetrain, or basically how the robot moves, you can avoid those obstacles. If it wanted to, it could also push those orange balls that are on the floor. And yeah, there's just a lot of different movements you can take with this robot you see here. So yeah, if you guys have any questions, you can let me know. And I know FIRST Robotics is like pretty niche. It's like a really specific part of the whole field and world of robotics, but this is kind of more related to us because we're all students. So yeah, we'll move on to controls. So yeah, the previous part, those were on mechanics, and I know later on we're going to have a lesson on just specifically the mechanical parts of robotics, which is like a whole entire different lesson. It has a lot of interesting parts to it. So yeah, if you wanted to know more, just stay tuned for that lesson. I think that's in a maybe few weeks, but here we're going to go ahead and talk about controls. So controls, if you hear the word controls, it sounds kind of weird, like controlling, whether it's like you're controlling the remote or something, but it's kind of the same, but the controls aspect, that has to do with wiring and a little bit of coding, but it's mainly those wiring details and all that. So, electrical engineering of the robot, batteries, that's what controls deals with. And there's also going to be like this wire hub on your robot. If you don't know what that is, a wire hub is basically kind of like the name says, just where a bunch of wires will meet or where you can organize all your wires. And wires are important, so that way you can get the motors on your wheels to move, you can get your batteries to actually power your robot and all that. So controls is really important. All these parts are really important: mechanics, controls, software. And the wiring also is really important to manage and direct the movement and functions of various parts of the robot. So it goes hand in hand with programming, and it's just really similar, really reliant on each other. So controls is really like wiring, a lot of wiring, and really reliant on the programming aspect as well. So Java, now we're going into more software related things. Alrighty. So Java is a programming language that is widely used in robotics and a bunch of other uses as well, of course, but right now we are more centered on FIRST robotics, as we've mentioned previously. So Java and JavaScript is really common in the FIRST robotics competitions. So Java is really helpful to know. And if you guys remember, in our first Girls in STEM session, we taught the basics of Java. So yeah, Java is just a really useful coding language. And yeah, next we'll go on. So methods. And this is just a little bit of more Java, but essentially a little bit of code, because this presentation isn't going to be about code, of course. It's about robotics, so I don't want to go too into the Java coding language. Just a little basics. It's possible to write a program only inside the main method, and you don't need to understand this image here on the right side that has like public static int. Don't worry if you don't understand any of that. You don't need to know that right now. But essentially, in robotics, if you want to get your robot to actually do anything, it's really important to have code. So coding is just as important as the whole building and mechanical, physical aspect of it. So when we write our code, we're going to use methods. And methods are basically like functions that tell the robot what to do. So let's say you want your robot to be able to move in 4 directions: forward, backward, right, and left. If you want your robot to do that, you need to code for each of those directions. Basically, let's say you have this like controller that allows you, or like a joystick that allows you to control that robot. If you move your joystick forward, that means the robot will also move forward. So you need to be able to code that. And when you code it or code these methods or functions, the really important parts of it is make sure it's not messy. And what you see here, oops, sorry about that, but here you see these points. This is what you don't want to do. And you see here it says messy, not reusable, hard to read, hard to debug, hard to write, hard to collaborate. And this is what happens if you don't use methods or don't use organized code. It's going to be really hard to get your robot to function if your code is just really messy and you're unable to actually like debug or read it. So just a lot of issues go along with just messy code. So yeah, those are some important aspects of methods. And I know there's a lot of coding related information here, but as I mentioned earlier, the coding aspect is just as important as the physical aspect of robotics. So we do want to go into this a bit. We have OOP. It says OOP or OOP. And I'm going to just say OOP because that's more fun to say, but that stands for Object-Oriented Programming. And OOP is used in robotics, of course. What that means is like Java. Java is an object-oriented programming language. And basically that means you're able to create different types of like certain movements or just do more advanced things with your robot. To describe it in the most simplest terms, because yeah, it's kind of hard to understand without going too deep into it, and you can do a whole nother lesson on object-oriented programming by itself, but because we just want to just briefly touch on this, we're not going to dive too deep into it. But one way to think of that is in an object-oriented programming language, you can have a class and have smaller objects within that. And don't worry if that sounds confusing. It's totally fine if you don't get it right now, but a quick example, let's say you create a car class. And in an object-oriented programming language, you can make objects within that class. So in my car class, I can create, a Mercedes object or a Nissan or a Toyota. So those are all different types of cars. So I have like this really broad object or this really broad item of car. And you can go more specific with different brands of cars like Toyota, BMW, Mercedes, Honda. Same goes for just like really anything. Another example is dogs. You can have a dog class, and then in an object-oriented programming language, you can have objects within that, such as different breeds of dogs, like a poodle, a pug, a bulldog, a husky. And essentially, yeah, that's what an object-oriented programming language is, and really helpful in robotics. That's why it's so commonly used. And yeah, more on software. Robots can be either manually controlled or they can be fully autonomous. So this is where autonomous code or software comes into play. And you can use a bunch of different programs to help with that, like computer vision, OpenCV, to create an autonomous robot. And just to slow down a bit, a manually controlled robot is basically where you have like a gamepad or a controller, and what that means is like you can press buttons or use like a stick to control the movement of your robot or what you want it to do. So basically there's like a human controlling the robot by pressing buttons or, rotating a stick. However, an autonomous robot is where a human is not controlling any of the movements. It's the robot itself, just like detecting the environment by itself. And it's not because it can think on its own, but it's because of the code. So code allows a robot to just fully act on its own, which is pretty cool. And it can be scary because we know if you see those sci-fi movies on like the Terminator or robots taking over the world, they're autonomous robots that can think on their own. But right now we don't have to worry about that. But we never know. Yeah, just something to keep in mind. So here, this looks kind of scary, this code. This is some examples of code actually used in a robot and FTC. So we're not going to go too into this, but just to kind of show you, if you're interested, we have different motors and claws and sensors. And this is just some code that shows us defining these physical parts of the robot. And this means we're gonna be able to like code that on later, so we can tell it what to do. Like if we have a claw, we can tell that claw to open or close, and so on. Some more methods. And we also have some code telling the robot to move. There's a lot that goes with it. So if you want to, we'll just take a minute so you guys can kind of just look at the screen and try and dissect it. I know it looks really scary, like there's a bunch of these like words on the screen that probably might not make any sense. But try and just read it and see if you kind of notice anything. We'll give you guys just 1 minute or so. Try and just read what the code says, and sometimes you might be able to like figure it out by yourself, but yeah, right now you might not understand any of it, but if you just slowly kind of look at each line, it might make more and more sense and you can figure out what this code does. So yeah, we'll take a minute or so and after that we'll go ahead and talk about it again. Alrighty, so hopefully you had some time to kind of look over this code. And yeah, if we read it, it kind of makes more sense because without reading it, it just looks like a jumble of words. But here If you see the words in blue, those are kind of like the summary of that line of code. So we can see break on the first few lines. That basically just means stop. Then we have forward, reverse, forward, and that just shows the direction of how we want the motor to go. So we can see where the bright pink arrows are pointing. Here we tell the motors to not run when they aren't being given any input from the controller. Then we have the three arrows in the middle. After the motors are initialized, this calls the motors and tells it either to rotate forward or backwards. Then we're calling those three methods. So of course we don't need to know about code right now because we're not focusing on code, but this is a general sense of what robotics code looks like in, in a robotics competition for FIRST Robotics and such. So yeah, those were kind of the main components of like the physical and software parts of robotics. And just the really last thing I wanted to touch on, because if we're talking about robotics, it's also important to kind of talk about current events related to robotics. So another really huge aspect of robotics is ethics. And ethics just deals with like, what's right and wrong and what you shouldn't do with robotics. And you've probably all kind of been exposed to this topic through, sci-fi movies talking about, robots taking over the world or robots hurting humans. And essentially that kind of is what robot ethics is about in the real world. And one example we have here is the ethics of drones. So basically war. And just a really quick summary. We have these flying vehicles or these autonomous aircrafts, and those are basically just known as drones. And also, by the way, drones, whenever you hear the word drones, you might think of those like camera drones that fly in the sky to take videos. But here we're talking about war drones, which kind of look like that image we see there, that are pretty huge and are used for war or like military or like shooting missiles. And they are used in the US military to target groups around the world. And there are good things about them, and there are also, of course, bad things. So, some good things about using these robot drones are that they don't place like humans in the military, of course, at risk. Because if it was a human that had to launch these missiles, then, there are a lot of kind of consequences that could happen. And, these robots are also, a lot more accurate than if a human was controlling it. And it also allows for just like faster and smarter decisions, more accuracy. And yeah, but of course, drones raise a lot of ethical issues because, a robot might attack innocent people. And there's a lot of ethical issues related to these robot drones. And same thing goes with something new that's been happening as well. So surgery can also be performed by robots. You guys might have saw like surgery on a grape where this grape was being, you know, um, like threaded together, you saw by a robot. The thing is, of course, once again, surgical robots also have ethical issues such as liability, lack of cost effectiveness, patient safety, and inequality. So, yeah, one famous example is the Da Vinci surgical system. That also relates to robo-ethics. And of course, as much as robots do a ton of great things in the world, like even your phone can count as a robot because it can do, it can perform a specific task. You know, robots have really improved our lives a lot, but of course, there are also a lot of issues to think about that come along with all the benefits of robots, because they can also do harm and, not so great things. But yeah, so that is all for the robotics prompt presentation for today. But overall, thank you guys for listening today, and that is all for the presentation. And yeah, we'll see you guys in the next lesson. So bye, and of course, if you have any questions, you can stay as well. But otherwise, we'll see you guys.